Well, so far we really haven't done any calculus in this section. We've actually done a review of some pre-calculus in finding inverses, domains and ranges, and when a function's one-to-one. The calculus would start with things like differentiability, continuity, limits, things like that. So notice this, because the graph of f inverse is the reflection of the graph of f, if f is continuous, the graph's all one connected piece, then f inverse is continuous. So you reflect it, the graph's all one continuous piece. So for example, down here, let's say that this is the graph of y equals f of x. Then this up here is the reflection. That's the graph of the inverse. I'm going to write x equals f of y, which is equivalent to y equal f inverse of x. So here's our graph of f. It's all one connected piece, so the reflection's one connected piece. That's how continuity follows. Also, if f is differentiable, then f inverse is differentiable. Remember, differentiability means that you have a tangent line. So if we pick a point on the graph of y equal f of x, so this is a point x comma y, that function's differentiable, then you've got a tangent line. And you can find the slope of that tangent line, and the value of the slope is the derivative. So we've got this line here that looks like y equals mx plus b. And your m is f prime at x, slope of the tangent. Well, since the graph of f inverse is the reflection of the graph of f, that means that f inverse is going to be differentiable. It's going to have a tangent line, not at x comma y, but at y comma x. So we're going to go straight through that line right here. That is the point y comma x. And you also have a tangent line there, and it has a slope, and that slope is the derivative of the inverse at that point. So we have a tangent line here. It is, the green line is the reflection of the blue line. And then this line is going to have an equation. It's going to be the inverse of this equation. And then its slope is going to be f inverse prime. So here, that's the tangent line, and the slope here on this line, I'll write that equation in just a second. The slope is going to be f inverse prime at the input is y. F inverse prime at y for the slope on the green line. Well, let's use properties of inverses to actually find that slope. So let's go ahead and find the inverse function here. So we want to solve, we're not going to switch x and y, we're going to write x in terms of y, because that's what I've written over here. So we're going to skip that first step, but we're going to solve for x in terms of y. So bring the b over as a negative, so y minus b is equal to mx, and then divide both sides by m. So m's cancel, you get x equals y minus b over m, which you can write that as 1 over m times y minus b. And then we could multiply that 1 over m in. So you get 1 over m times y minus 1 over m times b, so b over m. And that's our green line. So this is x equals 1 over m times y minus b over m. So notice that the slope on the green line is 1 over m. So f inverse prime of y is the slope at y, which is 1 over m. And what's m? M is f prime at x. So this is 1 over f prime at x. But we rewrote this as inputs in terms of y. So what is that x? Well, y is f inverse of x. So x is going to be f inverse of y. So I can write this as 1 over f prime. And then for my x, I can write f inverse of y. Right? If you take y equals f of x, and then you apply f inverse to both sides, f inverse of y is equal to f inverse of f of x. And then the f and f inverse cancel, and you just get x. So x is f inverse of y. So I put that in there. So there is our slope on the derivative function. So and that's actually the next theorem here. So the derivative of the inverse, if f is 1-to-1 and differentiable, then f, and if f prime of f inverse of a is not equal 0, actually that should be a y, f prime of f inverse of y is not equal 0, then f inverse prime at y is 1 over f prime at f inverse of y. Okay, and that's exactly what we got up here. Right there. So it comes from the graph and properties of inverses. Okay, well, let's put this thing to use. So here's an example. We want to find f inverse prime at 3 if f of x is x cubed plus 2x. So that 3, again, that is a y value because it's an input for f inverse prime. So inputs for f inverse and f inverse prime are y values, outputs are x values. So the first thing we have to do, let's go ahead and write our formula. So f inverse prime at 3, that y value is going to be 1 over f prime f inverse of 3. So 1 over f prime f inverse of 3. Okay, so what do we need? Well, first we need this f inverse of 3. Well, that's an x value, right? The 3 is a y value. You do the inverse of that 3, you're going to get an x value. It's the x value that goes with y equals 3. So to find this, what we do is we take our f of x, which is a y value. We take y, which is x cubed plus 2x, and we set it equal to 3. And then we want to try and find out, well, what's the x? And you just want to try and do this by inspection, plug in easy numbers. And notice that 1 cubed plus 2 times 1, 1 plus 2 is 3. So notice that x equals 1. So x equals 1, that's the x value that goes with y equals 3. So that's telling us since f of 1 is equal to 3, apply f inverse on both sides, 1 is equal to f inverse of 3. So this is a 1. This is 1 over f prime at 1. So now we just need f prime at 1. Well, our f of x is x cubed plus 2x. So f prime of x is going to be 3x squared plus 2. That's just power rule, right? Exponent comes down, decrease your exponent. Same here. And so f prime at 1 is going to be 3 times 1 squared plus 2, which is 5. So this is 5. So the f inverse prime at 3 is 1/5. So why don't you, for practice, before trying some homework, try this problem. So pause the video for just a second, try this, and then check it against my work. Did you get -1/5? So f inverse prime at -3 is 1 over f prime f inverse of -3. That's this formula. -3 is our y value. And the first thing you do is find your f inverse -3. So take your y function, set it equal -3. By inspection, I found that x was -1. If you plug that in here and here, you get 2 minus 3 minus 2, so that's -3. So x is -1. That's saying f of -1 is 3. I'm sorry, -3. So f inverse of -3 is -1. So this inside is -1, right there. And then f prime at -1, well, f prime at x, by power rule from this, is 8x cubed plus 3. F prime plug in -1, that'd be a -8 plus 3, -5. And so 1 over -5, -1/5.